So let's kind of put out the layout of how we're going to deal with percent increase, percent decrease, and the general way of doing it so that any kind of problem you get, you can really fall back on this general way and know you have it right. So, percent increase. So what does that really mean? Well, we know what percent means and we know what increase means. So how much you increase by relative to whatever original amount. It doesn't have to be original, it can just be whatever you're comparing it to. So if I'm comparing to, let's just say how much, if I'm making more money this year compared to last year, I'll take the increase. So let's say I get a $2 raise, and then I divide it by the original amount. So how much I was making last year. So last year was my reference point. So whatever the original is, and then times 100%, and the reverse for percent decrease. How much you decrease by over the original or whatever you're comparing to times 100%. So let's just do a quick and very basic rudimentary example. So year one, I made, let's say, $20 an hour. I never made that much, but let's just say you did. And then year two, you get $22 an hour. So now I want to know percent increase relative to last year. Well, we know that 22, 22 minus 20, that's a $2 raise. Now this is where you can really screw up. Now percent increase, whatever is at the bottom, so when it comes to percent increase, is what I'm comparing to as far as where I am now. So now I'm in year two. Okay, I want to compare to year one. If I was comparing year one to year two, year two would go on the bottom. But now I'm comparing to year one. I want to see how much I'm making now relative to before. And this is the before. So you do 2 over 20 times 100%, which is 1 over 10 times 100%. That's 10%. So I got a 10% raise. Let's just say you want to find how much I'm making this year relative to last year. Not the percent increase, but just how much I'm making in total. So I'm making in total this year $22 an hour over. Now, again, here's where it gets tricky. Now I'm comparing this year's to last year's, and last year's was this. You can see how it would be different if it was 20 over 22. It's a completely different number. So now you multiply that by 100%, and you punch it in your calculator, and this is what you get. And this percent increase, you kind of know when you have things right, when you kind of see a similarity between a 10-year and a 10-year. And this comes from the fact that, if you had 20 over 20, you're earning the same as last year. That's 100%. So 100%. That means I'm making as much money as I am this year as last year. But I got a 20% increase. So, you add the 2 over 20. That's just 10%. So this is what I'm making. This is what I was making. Plus how much I increased by. I get 110%. So it's kind of a quick way of checking if you got it right. If you get your percent increase and it's a certain percent, and then you do how much your new number, how much you're making now relative to last year, and then this should have some kind of bearing on it. So if it was percent decrease, then I should be like 100%, minus 10%, or something like that. This should play a factor when you're comparing, the total numbers. These are the total numbers. This is percent increase or decrease. So it's have some kind of bearing on your 100%. So now let's look at a quick example that we see in the lecture when it comes to suspended boiler. So suspended boiler, 24 meters away from the ceiling. And when it's operating and heated, it stretches by 13 centimeters. Now the first thing that you should notice is, hey, these are different units. You have to have the same units. Like I didn't do the previous example where I said, hey, I was earning $20 last year, and I got a 50-cent raise. I didn't do percent increase, 50 over 20 times 100%. I didn't say I got a 250% increase. You know, people look at you like, hey, you got a pretty big increase, but you'd be like, hey, no, it's, you know, I only got 50 cents. They have to be in the same units. And once the units cancel out, so if I had like something in dollars over something in dollars, you know how if you had 2 over 2, that really is like 1 over 1, they kind of cancel. So do the units. Dollars cancel out. And look, you're just left with percentage. That's why I always keep that percent unit, the last unit they use. So you know, you started out with the original. So original 24 meters. It's stretched by this much. So this was your change. So you know, you can represent it by a delta symbol, or you can just write it out as. So this is how much it changed by. Change slash increase, whatever you want to write. Equal to 13 centimeters. Now we can do two things. We can convert this one to centimeters and get a centimeters over centimeters, or you can convert the bottom one to meters and get meters over meters. It doesn't really matter. It gives you the same. So let's convert the bottom to meters. So you know, to get from centimeters to um, to meters, it's a factor of 100. So basically, what that means is for every 100 centimeters, you have 1 meter. Okay, or the other way around. It doesn't really matter how you write it. You know this. So now you'll take your 13 centimeters and kind of look at this and say, hey, I want to get rid of centimeters and have meters. So what am I going to do? I'm going to times 1 meter per 100 centimeters. So you know centimeters will cancel, just like how you cancel fractions that are across. Centimeters, centimeters. Now you're just left with meters. So 13 divided by 100, 0.13 meters. And that's how you kind of know you have it right. This technique is known as dimensional analysis. You can kind of, uh, in a lot of places, even in introductory physics classes, you can narrow down a formula by just looking at the dimensions and the units and trying to find out what you want. If you want in meters, hey, this is what you do. Okay, so we have meters and meters. So now you want percent increase. So as we've seen before, it goes, let's just take the meaning. Percent, by how much percent has it increased? So we increased, or whatever percent decrease. If you want to call it percent change in general, whatever you like. So you have 0.13 meters. That's how much it changed by. Divided by, what did we have? We had 24. Times 100%. So you know, meters cancels out. You don't really have to write this meters and meters cancels out, but it's kind of a good habit, so you know that you have the right units. So you punch out your calculator, 0.13 divided by 24 times 100, and you have 0.54%, and that's your final answer.